everybody!
This is Tim Wells,
Yamil,
and Alessandra Bisbal, and we will be talking about
Arctic Oscillation.
According to the Earth System Science Education Alliance, or ESSEA, Arctic Oscillation is a pattern of sea level pressure at the polar and middle latitudes in the North Hemisphere, which fluctuates between a positive phase and a negative phase. However, it can also be described as a series of circulating winds going counterclockwise. As wind goes through the poles, it is cooled down. The wind then goes to the equator, where it heats up, and then down to the opposite pole, where it cools down once more. This repeated cycle of cooling and warming is Arctic Oscillation.
This can be seen as a proxy for regulating forces in aquatic and terrestrial ecosystems. The AO has caused the climate to increase in temperature and has been in a positive phase since the 1990s. Its impact are seen in the intensity of winter weather, frequency or severity of winter storms, timing and volume of runoff, numbers of various fish, etc.
The trend of positive AO can be attributed to human activities. Ever since the 1950s, carbon emissions have increased dramatically due to these human activities. To name a few, there is the immense burning of fossil fuels, agricultural activities using fertilizer, and deforestation.
Arctic oscillation can be described as a feedback mechanism. These feedback mechanisms are divided into positive and negative feedback. Positive feedback is an exponential change or imbalance in reference to the equilibrium, while negative feedback is a pattern which aims to neutralize any deviation from an equilibrium and promotes stability, promoting back deviations to the equilibrium. Even though Arctic oscillation appears to function as a negative feedback mechanism, if we look at long-term effects on the biosphere, we can see that it is actually increasing by making the climate change exponentially hotter. Hence, it would be a positive feedback mechanism. When looking at Arctic oscillation, it is also important to mention wind currents, more specifically wind cells. When looking at our planet, we can see that there are three clear wind cells, each with a varying temperature. Polar cells are located in both the north and south poles, holding cold temperatures. The second group consists of the Hadley cells. These are located along the equator and therefore have the hottest temperature of all the wind cells. Between the Hadley and polar cells, we are introduced to a third group of cells, the Ferrel cells. Since these are between the polar and Hadley cells, these tend to neutralize air temperature and make it circulate to the next cell. However, there are also two phases to Arctic oscillation. The first one is positive Arctic oscillation, which increases the atmospheric pressure in the Hadley cells, and the second one is the negative Arctic oscillation, which increases the pressure in the polar cells. As carbon emissions increase, so does the melting of the polar ice caps. This triggers an increase in temperature in the polar cells, which reduces the amount in which the wind is cooled, therefore raising the entire planet's temperature. Due to this and other effects of climate change, several protocols and Earth summits have been implemented to form international agreements against increasing carbon emissions. Most notable of these are arguably the Montreal Protocol and the Rio 2012 Earth Summit, which both passed strict legislation on carbon emissions around the globe. Even though the world is slowly veering into an era of renewable energy and progress, there is still much work to be made.
A positive Arctic Oscillation Index causes the overall pressure and temperature in the middle latitude ranges to increase. We know that both pressure and temperature are linked by the Gay-Lussac law, which states that the two factors, temperature and pressure, are directly proportional to one another. Knowing that the AO index has been in a positive trend since the 1990s, we also know that the pressure and temperature have also been increasing. This trend causes the ocean to become more acidic. The reaction that causes this occurs naturally. Carbon dioxide reacts with water to form carbonic acid. This normally is at equilibrium. However, the positive AO index causes the reaction to be thrown out of balance towards the side of carbonic acid. According to Le Chatelier's principle, when the pressure increases, the reaction shifts to the side with the fewer moles of gas, meaning that we are going to create more carbonic acid. We also see the reaction shifting towards the side of carbonic acid when we consider the carbon dioxide emissions. Another property of Le Chatelier's principle is that when reactants are added to the reaction, we will shift the reaction towards the product side in order to achieve equilibrium. So we can also see that the increase of carbon dioxide in the atmosphere increases the amount of carbonic acid produced in the ocean. If this trend continues, it will reduce the surface ocean pH by 0.3 to 0.5 units over the next century, which will be the largest change in pH to occur in the last 20 million years.
The way the Arctic oscillation works is the opposite of the phenomenon El Niño. The AO starts in the atmosphere and then makes its way to the Earth's surface. It has been causing the ocean to have a thinner sea ice, which in turn affects organisms in the Arctic ecosystem because their homes are being deteriorated. More details about this will be provided later. Now let's talk about water. So water has quite a few properties, one being that it is the universal solvent. Some of its properties are that it has a high specific heat capacity, it has a high heat of vaporization, low density of ice, etc. The high heat capacity of water has a great deal to do with regulating extremes in the environment, and the AO is causing the ocean's water to heat up as well as the Earth's temperature, but it takes a lot of heat to get water to be hot. According to the USGS Water Science School, water has to absorb 4,184 joules of heat for the temperature of 1 kilogram of water to increase 1 degree Celsius. In addition, footprints of climate change are evident in marine ecosystems. For example, the Arctic or polar ecosystems containing polar bears, plankton, seals, walruses, penguins, etc. have been affected by the increase in temperature because it is melting their homes, which is causing them to spend more time in the warmer oceans where they are in danger since they have a chance of getting eaten by predators. As seen on Polar Discovery, changes in the food web not only threaten life in the Arctic region, but they also have impacts on Earth's climate. Populations of Arctic plankton, for example, not only provide food at the base of the food web, but they also convert carbon dioxide from the atmosphere into organic matter that eventually sinks into the bottom of the ocean, effectively extracting the heat-trapping greenhouse gas from the atmosphere.
Some possible consequences of Arctic oscillation are the loss of habitation in the tundra, increase in the speed of global warming, drought, increase in the amount of greenhouse gases in the atmosphere, and the acidification of the ocean.
Finally, some possible solutions are reducing carbon emissions with sustainable energy practices and improving infrastructure, government intervention, intergovernmental bodies such as Montreal Protocol or Rio Conference, NGOs, or creating protected areas such as national parks or wildlife reserves for animals who are affected and others who have the potential to be.